Welcome to EDU World Space.
So in this problem, we have an elevator that is traveling upwards at 2.5 meters per second and a bolt that is 3 meters away from the floor gets loose and falls off. And so what we need to do is we need to find at what time the bolt hits the floor of the elevator. So how we're going to solve this is by finding the motion using kinematics of each object. So first we'll start with the bolt, and we're just going to use our kinematic equation that we know, or one of them, which is going to be delta y. We're going to call it delta y1 is equal to v naught in the y direction times time plus 1/2 acceleration times time squared. All right, so if we draw how the bolt is going to go from the point of view of an observer, not in the elevator, the bolt's going to go like this, and it's going to come back down. And it's going to end around here. So that distance right there is our delta y1. So in our initial velocity, since the elevator is going at 2.5, our initial velocity is also upwards at 2.5. And acceleration due to gravity is 9.8, but since it's going downwards, it's negative 9.8 meters per second squared. So we can plug things in. Delta y1 is equal to 2.5 times t minus 1/2 divided by 9.8 is 4.9 t squared. And now we can look at the elevator. Since it's a constant velocity, there's no acceleration, we can use velocity is equal to distance over time. And so we have velocity, which is 2.5. The distance we're going to use is the distance after a certain amount of time. But it's going to be here, and then the floor is going to end up somewhere over here. So that's we're going to call it delta y2 is equal to delta y2 over time. Now we need a way to compare delta y2 and delta y1. So if this is our starting picture, I'll just redraw it down here. We have the elevator and the bolt. That's our starting picture. What it will lead to is something like this. Is the elevator is now up, because this is where it started from, right here. So that distance is going to be delta y2. And we know this distance is 3 meters. And then our bolt is going to start from up here. Start there and go all the way and land right there. So we know that starting here and ending where the floor is, that distance is our delta y1. So if we can compare these two, and we see that delta y2 plus delta y1 is 3 meters, right? But we got to be careful here, because this delta y1, it actually ends up being negative. So in order to compensate for that, you have to go 3 is equal to delta y2 minus delta y1. And so rearranging that, we can rearrange it to three is plus delta y1 is equal to delta y2. Now taking this equation real fast and just solving for delta y2, we have delta y2 is equal to 2.50 t. So now we can plug that in, right? So we have 3 plus delta y1 is equal to 2.50t. And then we can use our delta y1 formula we have up here and plug it in for there. So now we have 3 plus 2.50t minus 4.9 t squared is equal to 2.50 t. Of course, these 2.50 t's cancel out, so we're left with 3 minus 4.9 t squared is equal to 0. We can use quadratic formula for solve for t, and we get t is equal to plus or minus 0.782, but we're just going to use the positive because time can only be positive in this situation. So time is equal to 0.782 seconds. Now our next thing we need to do is find the speed of the bolt in relation to an observer and also in relation to someone standing on the floor of a building. So we're going to do that by using another kinematic formula. We can use the final velocity in the y direction is equal to 2.50. Sorry, let me write the variable. V naught in the y direction, which is 2.50, minus or plus acceleration times time. Solving that, or plugging the numbers in, minus 9.8 times, now we have t, 0.782. And so we find this final velocity is going to be equal to negative 5.16 meters per second. Now what this negative 5.16 is, that's the final velocity to an observer on one of the floors of the building, because that's not taking into account the frame of the elevator. So this is part C. We have the answer to part C, which is just going to be velocity is equal to 5.16 meters per second. Now what we have to do for part B is we have to take that number and do something with it with the velocity of the elevator. So of course, if you're in the elevator and you're going upwards, the bolt is going to look like it's going faster. So all we have to do is add 2.50 to that. So 2.5 plus 5.16, and we have velocity is equal to 7.66 meters per second. And last, for part D, according to the observer, we need to find the distance traveled between the ceiling and the floor of the elevator. So going back up, we're trying to find this delta y1, because we want to find that distance. So we can take the same equation, or we can use a different one. Let's use the same one. Delta y is equal to v naught y times t plus 1/2 a t squared, because now we have t. This is delta y1. Delta y1 is equal to 2.50 times 0.782 minus 4.9 times 0.782 squared. Solving for all that, we find that delta y1 is equal to negative 1.04 meters is how far the bolt fell before reaching the floor.